uh, on 2009, and it's a student-led organization committed to facilitate opportunities for sustainable energy enthusiasts. And actually, we believe that the students can have a positive impact on the energy transition. And our main vision is to act as a key facilitator in the sustainable energy transition and being a very practical platform in order to connect students, industry, professors, alumni, and different organizations within various fields of energy, industry, and research. And we also have a lot of lunch lectures provided. Some of them are also being hybrid and online, and some of them are in person. And then we also have a lot of excursions, visiting to different companies, organizations, and case challenge days. And these kind of activities. So from here, I'm gonna give the floor to my friend from NTU University, Sarwash.
Thank you, Parisa. So NTU Clean Energy Club is also a student-led club. It was formed in 2020, and we focus on mostly clean energy projects. It's a career-oriented club, so we have a platform for students who are have an ardent interest in the field of clean energy. And as a career-oriented club, we provide the opportunities for a member to work closely with our industrial partners. Apart from that, we also organize hackathons, and we organize symposiums like these. So NTU Energy Club is relatively new and we are growing. So yeah, I think that's it from the NTU Clean Energy Club. I'll keep it short. I would pass on my time to Anokhi to introduce the IIT Bombay.
Hello, I'm Anokhi Mehta and I'm the manager at IIT Bombay's Energy Club. So at IIT Bombay's Energy Club, we're building a community of students and professors and researchers who are interested in the field of energy. And these are from both inside the IIT Bombay campus and also those outside. And we attempt to provide exposure to various verticals of energy and also bring about climate change and sustainability awareness. So we have quite a few versatile activities, like we have industry collaborations, and we conduct projects and competitions through that. And we also have networking sessions and quizzes, games, and even some fun trips to startups or power plants, and also DIY projects for those who are interested. And in addition to this, to help students achieve sustainability goals on campus, we also have Team Zero Waste, which is working towards zero waste in campus and also other sustainability initiatives. So yeah, thank you for that. I think we can begin with the symposium now. So our first topic for today is hydrogen. And we have Professor Subodh Maisalkar from NTU, who's going to talk to us about that. Handing over to you.
So I just stop sharing and you can start sharing your screen. Thank you.
And since we are ahead of time, I think Prof. Subodh can take more time. Yeah, initially we planned it for less, but yeah, we have more times on our hand. Yeah.
Sure, great. Thank you. Can you hear me and see my screen?
Yes, we can.
Yes.
Okay, so it's my pleasure to be here. As you probably may or may not know, yes, I'm in NTU Singapore, but I'm a graduate of IIT Bombay. So it's a pleasure to be here representing, in a way, two organizations. So the topic that I just want to focus on is really how hydrogen will empower the energy transition. And I'm really not going to go into a lot of technical details. I personally thought that it would be a better idea to pose questions and wait for more interactions than slides. I think all of you are aware of hydrogen and really in the sense what it is composed of. What I really wanted to highlight in this slide, however, is one of the major advantages of hydrogen is its high energy density. And the high energy density part is seen in this chart on the right hand side bottom. Maybe let me try to switch to a pointer option here. And this is where it's understandable that hydrogen in terms of its gravimetric density is a huge advantage, and started off in terms of getting applications from a space perspective. There is plenty of hydrogen available in the world. However, the challenge with hydrogen is you cannot derive hydrogen in its native form, and we will cover the sources of hydrogen. But on Earth, it really is the fundamental a building block of every form of life on Earth. From a generation perspective, very often you would speak about hydrogen in terms of three different colors. You would speak of gray hydrogen, blue hydrogen, and green hydrogen. And gray is where you would start with methane, and you would send it through a steam methane reforming. In this process, one of the reasons it's called gray is that the carbon dioxide is not captured, it's released, and that is a major issue. On the other hand, this is a mature process, and it is really because of its maturity and scaling, it is probably the lowest cost of the lowest form of hydrogen in terms of cost, which is available today. The blue hydrogen can follow a very similar route as the gray hydrogen, except in this case, you're going to be capturing the CO2, and that adds at least 40% in terms of the cost to the gray hydrogen. Really, the ultimate that all of us are working towards is the green hydrogen, and that has to go through splitting of water. The costs can vary quite a bit because a lot of this technology is far from mature. And the main costs that contribute to anywhere between, some people say as low as $3 per kilogram to $10 per kilogram. The costs are attributable to electrolyzers, to catalysis, catalysts, as well as the source of renewable electricity. We also have to remember that green hydrogen comes from water electrolysis, and you also need a fair amount of water to make this happen. And estimates are you need approximately 11 liters of water to make 1 kilogram of hydrogen. And even the water needs to be in pure form. At this point, it's difficult to use seawater for electrolysis. It's not impossible. That's something people are working on. There are many, however, advantages of hydrogen, and I mean one of the considerations in terms of use of hydrogen in end use, such as chemical industries, power generation, as well as transportation, is how not only do you produce the hydrogen, but how do you get the hydrogen from the point of production to the point of end use. And this can happen, of course, the simplest form is it can happen in terms of cylinders or pipelines, and that is in terms of gas. It could happen in terms of cryogenic or pressurized form. And in this case, you would transport it in some form of a tanker or from a cryogenic liquid perspective. Of course, there is one possibility where you could send it through a pipeline to storage and eventually use and extract the hydrogen back from geological storage for utilization. One last aspect that I will touch upon later is really to use this convert that into some form of a chemical, and I'll address what chemical it is, and transport it using conventional petroleum-based tanker technology. So please remember, it's not just the cost of hydrogen for production, but the delivery of hydrogen and what is sometimes referred to as the landed cost of hydrogen that matters more than purely the cost of production of hydrogen. One of the main advantages of hydrogen, especially from a power production perspective, is it gives you the role in terms of buffering. And this is beyond what a battery can offer. Battery can offer storage for maybe 1 to 2 days. There are a variety of different sources, including compressed air, that can offer a little bit longer. Pumped hydro is definitely a viable source, but hydrogen, if stored properly, can give you seasonal bufferage and really also strategic reserves, like it can be done with petroleum. And that is a very significant point to note in terms of hydrogen. So what I wanted to spend the next couple of slides on is to look at when and where hydrogen would be first used, and what are the barriers, and those are the questions to be addressed. towards the roundtable or the discussion sessions. What are the barriers to be addressed in terms of utilization of hydrogen? So the first area, which is really in my opinion, the low hanging fruit, is utilization of hydrogen for power generation. Just to take Singapore as an example, 42% of Singapore's emissions comes from power generation. Currently, we are using 95% of the power generation in Singapore is using natural gas, and substitution from natural gas with hydrogen would really make a huge difference. So the question is, how can you make this happen, and what would be the timeline in terms of when it is possible? So if you see the x-axis here, the x-axis speaks about a market share potential by 2050. And a lot of us who are really in the sustainability research really dismay at the possibility that very little hydrogen would be used in power generation by 2050. And this is puzzling. The main reason, and I won't get into a lot of details about it, the main reason for this, there are probably two key reasons to address. The first reason is the cost. For this to be cost effective, the cost of hydrogen, landed cost of hydrogen in Singapore, for example, needs to be under $3 per kilogram. And it is estimated in terms of its current projection, the cost of hydrogen in 2050 in Singapore would be close to $4.90 per kilogram. And that is the differential that really will interfere with its utilization. Of course, it's a no-brainer to say that if I use hydrogen, the only emissions are going to be water, and that will reduce significantly the emissions from power generation. The second factor, which is a barrier in terms of utilization in power, is that the turbines that are needed to burn hydrogen are far from mature, and a lot more development would be needed, and probably 1 or 2 generations would be needed, 1 or 2 decades would be needed before equipment becomes mature and commercially available. There's probably a third factor, and this factor is definitely a factor around the world, that investments in power generation really last for at least 20 to 30 years. So it is, I mean, it's really from an economic perspective, it is difficult to argue for obsolescence before the end of life of the equipment. And those are probably the 3 key factors in terms of the barriers to implementation in terms of power gencos. In transportation, the implementation will be much faster when it comes to applications, for example, in forklifts or in buses. But as far as small cars are concerned, where the travel distances may be 50 kilometers per day, the transition to hydrogen would really be significantly challenged by battery electric vehicles. For a simple reason, the battery electric vehicles will give you almost 70% well-to-wheel efficiency in terms of energy, whereas something like hydrogen and fuel cell give you an efficiency of less than 30%. So it is that factor for city transportation, which will mean hydrogen in a lot of places in cities. I mean, the transportation may still be battery electric vehicles, but for long distance, heavy duty buses or forklifts, hydrogen makes perfect sense. Maybe in terms of interest of time, let me jump to industry feedstock. So the potential for 100% utilization of hydrogen in terms of industry feedstock seems very, very promising for applications like ammonia or methanol or specialty chemicals or refining. And the reason is very simple. The reason being, even today, we rely heavily on hydrogen in terms of the feedstock itself. Taking a slightly different view in terms of the same question on when the deployments will take place, I've already indicated in the previous charts that some of the early implementations you will see would be in applications such as forklifts or refining ammonia and methanol. And let's take a look at what timeframes we will see these transitions significantly kicking in. And you would see probably by 2025, a significant transition towards use of hydrogen in coaches or trucks. We will begin to see probably by 2030, use of hydrogen for high-grade industrial heat. And this could definitely include applications in refining or other forms of applications, including the refining of iron ore or other applications of metals. From a power generation perspective, I think we have already indicated that it'll be easily in the 2040 onwards that this will be visible, and some of the reasons I've already covered, so I won't cover some of these further. Some of the barriers in terms of hydrogen utilization are throughout its value chain, and the value chain, as I mentioned earlier, starts with production, but storage is an important factor, and use transportation is an important factor, infrastructure upgrade, and really readiness would also be important. I did not mention in the previous couple of slides, but just to take one example of really from an infrastructure perspective. If you start planning for hydrogen refueling stations, the estimate that we've made in Singapore is you would need per hydrogen refueling station 4 times more land area than you would need for a petrol-based gas station or for a petrol station. The reason for the 4 times land area is straightforward. It needs that extra land area from the perspective of buffering from a safety perspective. So in certain countries, 4 times more area for a petrol station equivalent would not really cause a major challenge. But from a land scarce perspective like Singapore or most mega cities around the world, we may not have extra land area for catering for the extra buffer which is needed. But it's not just the buffer from the infrastructure perspective. There are considerations of transport, there are considerations of storage, and some of these I'll touch upon in the later part of the presentation. Let's look at the various options that I mentioned earlier, which included the gray or the brown hydrogen, the blue hydrogen, and the green hydrogen from a cost perspective. I did indicate that at this point, steam methane reforming and sourcing hydrogen from fossils is probably the lowest cost option. And options in terms of combining SMR along with carbon capture can increase the cost a little bit, but it is still viable. But from a long-term perspective, what we are targeting is a variety of sources of green hydrogen. And just to orient you with the acronyms on the x-axis here, this is basically alkaline electrolysis. This is PEM-based electrolysis, or proton exchange membrane tape-based electrolysis, or solid oxide electrolyzer cells from a electrolyzer perspective. And at this point, a lot of different countries and a lot of different companies are betting on alkaline electrolyzers because this is the oldest technology, and significant progress has been made in recent years in terms of both its scaling as well as cost. But this is something that we need to keep in mind, that for green hydrogen, a significant amount of breakthrough needs to take place in terms of from a cost perspective. And this is something that we are working on, as well as a lot of different people are working on actively. So that is on the generation side. The transportation side is also definitely challenging. You can either, as we mentioned earlier, you can either compress it or you can convert it into liquids. And the liquid conversion needs really cryogenic forms of conversion, but this is not entirely challenging. We know how to transport, how to convert natural gas to cryogenic form, and also how to transport it over very large distances. So the same know-how and the infrastructure can be used in terms of transporting cryogenic hydrogen. One of the major, I'll come back to that in a minute. The other possibility of conversion or storage is, of course, to convert it to ammonia. And eventually, once you transport it to the end use location, you go through an ammonia cracking, and you would liberate hydrogen and utilize nitrogen in some form or another. There is another aspect which is becoming quite interesting, is where you could mix hydrogen with, for example, toluene, and there you have a liquid chemical that could be transported using tankers. And we know very well how to handle petroleum-based transportation, and that becomes one form of transporting hydrogen safely. At the end-use location, you would go through again the process of liberating hydrogen from toluene, and what gets returned to the source location is, for example, pure toluene or different forms of organics get returned. So why am I covering transportation? I think there will be a few countries around the world that will focus their economies on producing hydrogen and exporting hydrogen. One of the key countries which is already gearing up to play a role in that process is Australia. So for example, countries like Japan or Singapore are seriously considering importing hydrogen from places like the Middle East or Australia, or even Central Saharan Africa. And so the transportation becomes a key factor. But there is a secondary factor that comes in now as well. Imagine at the end use location, you have either ammonia or some form of a liquid organic hydrogen carrier. The percentage of hydrogen per kilogram of either ammonia or a liquid organic hydrogen carrier can range anywhere between 6% to 18%. So really a lot of weight which is transported is really the carrier and not the hydrogen itself. On the other hand, if you're transporting cryogenic liquid, then 100% of the liquid which is being transported is hydrogen from a weight perspective. So purely from a number of cargoes perspective, I think the number of cargoes or number of tankers which are received in the port would be a lot lesser if you had cryogenic hydrogen, as opposed to you have other forms of transport. And that becomes a significant factor in terms of the ability to receive hydrogen at a distant location. The other aspect, ultimately, it all definitely, the consideration comes from a landed cost perspective. And this is really how the forecast is for landed cost of hydrogens between now and 2050. And I mean, really to keep this chart very simple, what this chart tells you is the landed cost of hydrogen, including carbon capture, is lower if you use fossil fuels. The green bar here is indicating the cost of hydrogen based on transportation, for example, from Australia. And it'll still be a little bit in the range of $4, and it'll be more expensive than so something has to change in terms of what it would take to produce hydrogen in a cost-effective manner. And a lot of different activities are being pursued around the world to make that happen. So for example, in the US, there is a moonshot program which is targeting by 2030, the cost of hydrogen generation should be less than $1 per kilogram. There are similar efforts in terms of ambition in both Japan as well as Australia. And this is a space that we need to watch actively before hydrogen becomes a viable vector in terms of our journey towards net zero by 2050. This also from a learning curve perspective tells you what the forecast is in terms of cost reduction from hydrogen. And I think this chart is also interesting because it also gives you how wind and solar has perhaps performed over the last decade. I think all of us are aware of the price drop in terms of solar electricity production. A similar drop has been seen in wind, and a similar drop in prices has also been seen in cost of battery costs over the last decade. So at this point, the forecast is in terms of the cost of electrolyzer or fuel cell, the forecast is to drop by 10 or 20%. And really to change this curve is what all researchers are targeting. And really the question that we are asking is, we were wrong in terms of the forecast in how fast the cost of solar or how fast the cost of wind would change over the last decade. What if new technologies become available and we can have similar scaling and cost reduction in terms of hydrogen? So I think it'll be really exciting to see if we can reduce the overall cost of hydrogen and make it cost effective, not by 2050, but perhaps somewhere between 2035 and 2040. And that would make a really huge difference in terms of utilization of hydrogen. And that is perhaps where I want to target the last slide before I summarize this presentation. The forecasts at this point say that in the next 10 or 20 years, the gray hydrogen will probably be one of the key major suppliers in terms of hydrogen supply. It will be eventually replaced by blue and hopefully faster by green. So I just want to ask two scenarios more from a what if perspective. What would it take to massively scale up blue hydrogen, really completely displacing gray hydrogen? And it is possible, but really what it would mean is we need to scale the possibility of carbon capture and utilization, or carbon capture and storage. And what would really be what we would need is a capacity of 50 gigatons by 2050. And just to compare and put this in perspective, our current capacity is less than 0.1 gigatons. So massive scaling would be needed. Of course, the second factor is we have not factored in the cost of carbon in any of this discussion. So if the global cost of carbon is significant, then the transition towards blue and green hydrogen will be accelerated. So on the other hand, if you see what would it take for us to really go for a green hydrogen world, what we would really need is a very significant scale up of our capacity of installing additional renewables. We also need to look at very high capacity of electrolyzers. And overall, what we would need to invest in is not just the cost of renewables, and the cost of electrolyzers and so on, but we also need to modernize our grids. So the grid aspects I'm not touching, but I think it is possible to dream of a blue or a green scenario, but significant investments would be needed. We have the technologies. What we need to really ramp up is the cost reduction of these technologies, as well as massive scaling. So what I want to end up with is to summarize. I really did not have a chance to talk about what is going to happen by 2050. I think it is very clear that if we take the current projections, even the optimistic projections, we will still need 40 to 50% of our source of energy would be fossil based. We need to displace that. And it's not just net zero is not going to be enough, but we really need negative carbon technologies if we really want to dream of a world where we limit temperature change to 1.5 degrees or lower. And for all of this, hydrogen is definitely an enabler, both for net zero as well as for below zero. From a purely hydrogen perspective, we need to address the supply chain. We need to address safety, as well as really from a cost perspective, every form of renewable energy sources need to be scaled up. And from a deployment perspective, I think the priority should be to displace power generation, but industry and transport are the close second and third in terms of applications. And the target would be, how do we bring the cost of hydrogen? I mean, I'm putting down $4 here in terms of landed cost, but really to be cost effective, it would be great to bring it down from a landed cost perspective to under $2 per kilogram by 2050. And I hope that all the young people on this call take this upon themselves as a challenge to really beat the forecast, and that we achieve this not by 2040, but perhaps by 2030 or 2035. And I think I will stop my presentation at this point. Thank you so much.
Thank you, sir. It was really insightful. And for the participants who have questions, we'll be having a Q&A session at the end of the panel. So our next panelist for today's discussion is Dr. Rahul Valavalkar, who leads emerging technologies and markets practice for customized energy solutions. And he's also the founder and president of India Energy Storage Alliance and the chair for Global Energy Storage Alliance. So handing over to you, sir.
Thank you very much, Anokhi, and thank you very much for Dr. Subodh for providing an excellent overview. I think he has made my job much easier, so I can maybe run through my presentation a little bit quicker than what I had originally anticipated. So let me just share my screen. Can you guys hear me okay?
Yes, we can do.
Okay. And also I'll share the slides at end of the presentation with Anokhi so that you can distribute it with all the participants if required. Yeah. So I'm Dr. Rahul Walalkar. I am President and Managing Director for Customized Energy Solutions India, as well as founder and president for India Energy Storage Alliance. Customized Energy Solutions is a global energy consulting and services company. We work across the electricity sector. I specifically lead our emerging technology practice, which looks after areas like smart grid, microgrids, energy storage, e-mobility, green hydrogen, and other emerging technologies. But one of the key strengths of Customized Energy Solutions is we work with more than 700 clients across the complete electric grid stakeholders, right from the generation companies to transmission distribution companies, large commercial industrial users, various technology companies who are developing these emerging technologies, as well as investors and policymakers. We also operate more than 15 gigawatt of assets around the globe, including large wind farms, solar farms. We manage a lot of behind the meter assets on behalf of customers and bring in the flexibility from the customer side into the grid through demand response program. And one of the fastest growing portfolio has been energy storage assets, where currently we manage more than 1.5 gigawatt hour of assets and co-optimize those with either generation side resources or behind the meter resources in different electricity markets. We also have been operating in India since 2010. And we work with our clients in providing them with market advisory, strategic advisory, technology consulting, and market operation services. Here are just some of the names so that you know the credentials in terms of the work what we have done on the strategy consulting with various technology companies. So the companies will be quite familiar, but we work behind the scene with the management for helping them develop their roadmaps and investments in this area. These are some of the other global clients for emerging technology practice for CS. And India Energy Storage Alliance was the initiative which we launched in 2012 because we were convinced that energy storage technologies, not just batteries, but all form of energy storage technologies can transform India's electric grid. And to help in creating awareness, we created IESA with just 5 member companies in 2012. I'm happy to announce that we are celebrating 10th anniversary this year, and we have now crossed more than 165 member companies, which span technology companies, project developers, EV companies, EV charging companies, green hydrogen companies, research universities, startups. And plus, we have more than 30 national and international strategic partnerships where we try to, one of our goal is that there are so many exciting things to do. There is no point in duplicating efforts. So we work with various partners globally to ensure that we are maximizing the awareness creation as well as the market creation in this area. As a IESA, we have over the years launched very specific initiatives in different areas, including one which is of interest to today's topic, which is the MIGHT initiative, Mobility and Infrastructure with Green Hydrogen Technologies. And we have some of the companies within IESA network who are specifically focusing on green hydrogen are highlighted on the screen, but there are many more companies who are now looking into green hydrogen as an area. And Professor Subodh has very well covered the complete background of gray, blue, and green hydrogen in his presentation. Now, one of the key areas where we work on is the policy side. And this is the area where you need to have a lot of patience. So again, if you see the overall energy storage related policies have evolved from 2013, where first task force was set up by Ministry of Power and CA to look at the large scale renewable integration. But that time the large scale renewable had a different perspective, right? So that time the Ministry of Power was looking at maybe integrating somewhere around 20 gigawatt of renewables by 2020 as a target, of which majority would have been wind, and then they were looking at scaling up solar to 20 gigawatt by 2022. All of this changed suddenly in 2014 with Honorable Prime Minister Narendra Modi ji escalating the targets with increasing, especially solar going from 20 to 100 gigawatt in the same timeline. And since then, we have seen that focus on renewables has steadily increased. And now currently we have the target for 500 gigawatt non-fossil fuel generation, which will be mainly wind and solar, but maybe some hydro and some biomass to be installed by 2030. And this is an area where all forms of energy storage technologies are critical. We were involved in drafting the National Energy Storage Mission, which covered all technologies, including green hydrogen. But then in 2019, there was a specific mission which ended up getting driven by Niti Aayog, focusing on e-mobility, focusing on the battery technology. And that's where then MNRE felt a need for creating separate mission for green hydrogen as well. So as IESA, we have been involved in this entire process of policy making. And I hope that many of the students who are participating in this webinar will also choose to work very actively on these policy scenarios, because this is really exciting, where you can bring in understanding about the technology, understanding about the market, as well as various policy and regulatory tools together to try to advance the market and implement things on ground. So Professor Subodh has very well explained about all shades of hydrogen. In fact, there is a much wider palette available now, where there are turquoise, pink, and all other shades of hydrogen are also being talked about. But primarily, you think about these four shades of hydrogen, of which probably brown is not of much interest right now because of obviously the carbon intensity of brown hydrogen. I think gray hydrogen is right now the most dominant technology. I'm not sure if Professor Subodh mentioned it on one of the slides, but right now more than 95% of the global hydrogen which is generated is with gray hydrogen, or possibly the number could be closer to 98 as well, depending on the countries. But what we have decided as the India Energy Storage Alliance to focus on is green hydrogen, because that's where we feel that there are a lot of synergies in terms of the policy direction which Indian government has taken, and where we as customized energy solutions believe in terms of the technology pathway going forward. I think rather than spending energy and efforts on looking into gray or blue hydrogen, we feel that there are a lot better and exciting pathway forward for green hydrogen. So I will focus completely my presentation on just looking into green hydrogen areas. That doesn't mean that there is no other activity happening. It is just that based on our limited understanding, we feel that's the best area to focus on, considering all the other environmental and emission related targets what we have as a community. We launched 3 years back the MIGHT initiative to bring together focus on this area. We have been working mainly with international partners in this area, including MENA Hydrogen Alliance, Greenstat Hydrogen Alliance from Norway, as well as World Resources Institute in this area. And here also we are specifically focusing on green hydrogen because there is a lot of noise, and sometimes people get too excited with almost every opportunity which theoretically is possible, and especially on the policy making side it becomes very, very scary, because I have seen it already in last 2 years where suddenly people have started talking about green hydrogen as a solution for everything, right from not just buses or trucks or heavy duty transportation, but even going down to the electric two-wheelers or three-wheelers. And I think sometimes again it is always fine to work on certain innovation and try to work on certain product and break through the status quo, but if you start influencing your policies and start creating sort of barriers for other existing technologies or slow down on your focus on that, then that can be actually a negative impact. And that's a part where I think through the MIGHT initiative, as IESA, we are trying to ensure that there is a laser sharp focus on green hydrogen on applications which make practical sense, particularly for India. And then also it doesn't end up diluting focus on some of the other areas of e-mobility or the stationary storage, which is right now much more commercially viable, and we need to bring in focus on implementation of that. So we are looking at this initiative as a way for making sure that we don't end up clouding the especially policymakers' views in this area. I think Professor Subodh has explained this very well, so I won't go into detail. But out of the key areas which we have talked about under MITE, we are focusing on commercial applications, commercial transportation like trucks, buses, or marine, and especially industrial applications where primary focus is on oil refining and fertilizer. But we think in the long run, cement or steel or some of the other industrial areas could also be a key user for green hydrogen for India. We think on the power side, it will be more about use of the renewable energy. We don't right now see in India the role of green hydrogen for either something like burning into gas turbines or those things, because right now in India, gas generation itself is a very small part of the portfolio, and most of the gas generators which were built in India are actually stranded assets right now, with the gas generation not being economical even with natural gas. So try to replace that natural gas with green hydrogen, at least for next 5 to 10 years, is a distant dream. So that's where we are focusing on the commercial transportation as well as some of these industrial applications as a key area under the MITE initiative. And this is not something which is just our own view as a customized energy solutions, but over last 2 years, we have done series of stakeholder consultations involving not just some of the top minds in India, but also we have invited many of the international experts and try to learn from them, and then try to sort of map that with the ground realities here in India. So, as I mentioned, Indian government has been working on green hydrogen mission. So we have been regularly providing inputs to both Niti Aayog as well as Ministry of New and Renewable Energy on various drafts which are been created. And what we are excited about is that it looks like that the ministries have especially the petroleum ministry has taken a lot of learning from some of the mistakes which we did on policy side in last decade, where we ended up sort of just waiting for reverse auctions or waiting for scaling up of the technologies on the manufacturing side, and not focus much on the systematic deployment and scaling up of the market, where everyone had like these targets for 10 years or 20 years down the line, which were in hundreds of gigawatt scale. But then right now, practically on stationary energy storage, the largest project which we have deployed so far is only 10 megawatt scale. And suddenly there are tenders which are coming up, which are at gigawatt hour scale. And that is something which is a significant problem for industry, because there is just not sufficient capacity which we have built in industry to execute these gigawatt hour scale projects. So with green hydrogen, one of the recommendations what we provided to government was that we need to change that. We need to, rather than waiting for some arbitrary price point to be reached, like I think Professor Subodh already talked about the US Department of Energy moonshot of $1 for hydrogen, and it's perfectly fine to have those long-term goals. The problem is that many times when you're looking for actual RFP and projects, people start delaying decisions because they think that some of those targets are very realistic or very near term, and you suddenly end up losing 5 or 10 years with that. Now, instead of that, what we have recommended is that if we start focusing on blending, because already India has a significant market for gray hydrogen. India is consuming somewhere around 6 to 8 million metric tons of gray hydrogen for existing applications. Now, if we start with just even 1%, 2%, 5%, 10% kind of a blending, then even when green hydrogen is costing $8 or $10, the effective impact on the gray hydrogen price or the hydrogen price used for those applications would be minimal. And especially if this comes as a green hydrogen obligation, then there is a level playing field, because every petroleum refinery or every fertilizer industry has to meet with those blending targets, and everyone will be at the same level. And then that will create a market opportunity where we can invest in scaling up manufacturing for electrolyzers or storage or other areas, and try to basically make sure that there is a steady market opportunity available, rather than just waiting for Norway or Germany to develop the best electrolyzers and start importing those 5 years or 10 years down the line when the economy of scale has reached. Because many times India has especially missed out on the opportunity for manufacturing, because when technologies were costly, we did not provide enough market, or wherever we provided market, like in case of solar, the focus was just on finding out the cheapest available technology, and that ended up not creating enough incentive for people to start investing in early manufacturing in India, and we have become dependent on China for completely majority of the technologies, both for solar as well as for batteries. Right now, more than 95-97% of the cells which are being imported, either solar wafers or the lithium-ion cells, are being imported from China. So we think that with green hydrogen, we can learn from these mistakes and try to address that by providing such steady market, which can keep on growing over the next 5 years or 10 years. And we are very excited that although there were a lot of discussions and there were a lot of academic focus on blue hydrogen, I think Prime Minister Modi ji has very clearly understood that the pathway for India is green. And he actually last year, as part of the Independence Day speech, very well announced that India's national hydrogen mission will focus on green hydrogen. And we are super excited about that, because again, blue hydrogen is perfectly fine to try, but the way we are looking at growing the renewables and rest of the target, I don't see blue hydrogen playing a very critical role in at least India's path forward. So in the National Hydrogen Mission, as I mentioned, the first step is to create demand. We need to make sure that there are also some early pilots which are created for some of the future industries such as steel or transportation area or chemicals. We need to look at gas blending, but they're typically, with the current kind of gas pipeline and infrastructure which is available, my understanding is maybe 5 or maximum 10% blending of hydrogen with natural gas will be possible. Beyond that, we need to actually replace the complete gas pipeline infrastructure and make sure that the gas pipelines are suitable for carrying higher percentage of gas. So it is not just something as simple as replacing existing just pipelines and just shift from natural gas to hydrogen because of the chemical characteristics of hydrogen. In terms of the infrastructure, we need to start focusing on creating hubs where you can generate the green hydrogen and consume it locally. Because right now, I think the storage of hydrogen, and if you are trying to shift transport it and then use it again, then that adds significant additional cost, and based on some estimate, that cost itself can be additional $3 to $5 in terms of just the transportation cost. So at least the initial volume for the market needs to come up from the areas where there is a synergy between the green hydrogen generation and industrial hubs. And we have already identified 4 or 5 such hubs in India where there is a significant concentration of either fertilizer plants or petroleum refining, and that can become a starting point. As I mentioned, the current consumption in India is around 6 million metric ton, and it is expected to keep on growing. And if you see the original projection from Terry, which was done, actually showed the entire market for green hydrogen being created only beyond 2030. And we think that that scenario we cannot afford. We have to basically shift that to at least 2025, if not sooner. And that's so the complete policy focus and effort what IESA we are doing, because we think that this approach of just waiting for prices to fall down because of some other external factors and then try to create a market for that, that is a very harmful policy strategy, and that would not create any opportunity for R&D and manufacturing in India. Most of you will have to go outside India to try to develop your careers, and we definitely want to change that. As I mentioned, the primary focus is on refineries, fertilizers, steel and methanol is another area, but which, unlike refining and fertilizer where you are just sort of blending gray and green hydrogen, with steel, actually it's a completely different process. So you have to look at a complete greenfield project, and that's where we feel that with steel it will start with certain pilots, but then again with the current green hydrogen pricing, it is very difficult to make the steel manufacturing economical unless there is some other factor where people are ready to pay for green steel. So we think that the steel demand will come up, but that will come up towards sort of maybe the second half of the decade once the prices starts getting closer to maybe $3 or $4 or below that. In terms of the transportation, we think there is an opportunity for heavy duty transportation, but rest of the transportation like rickshaws or two-wheelers or others, or even cars for that matter, although Toyota, one of the members of IESA, is very active in this area, For India, we think there are limited opportunities for looking at hydrogen in those sectors, but especially for trucking and long distance buses, this could be a good option if we focus on it at an appropriate level. The good part is that in India, many industries have actually woken up, similar to the focus which is right now happening on advanced battery manufacturing, where there are around 20 large industrial groups are investing in gigafactories in India. In hydrogen also, there are 5-6 major players have stepped up, including Reliance, which is investing into both cell manufacturing as well as green hydrogen electrolyzer manufacturing. Larsen & Toubro is another company which is investing in both, and Larsen & Toubro has recently also announced a joint venture with Renew Power for supplying the green energy, as well as with Indian Oil, which will be the consumer in terms of the petroleum industry, for bringing or fast tracking the work on green hydrogen. We are also seeing, I think, in terms of the refinery, Indian Oil, HPCL, and other oil PSUs are putting a lot of effort and focus on this area. And you will keep on hearing a lot more announcements from these public sector units as well as their partnerships on private sector in the coming months and years in this. On the fertilizer side, again, we think that it makes a perfect sense for blending green hydrogen. And there are already 2 fertilizer companies who are already starting with the pilots. And we think even since the sector is dominated or is almost split 50-50 with private and public sector, with the government push, we can see the faster adoption of green hydrogen in fertilizer sector. In steel, we are seeing there are announcements which have come up in terms of doing some of the pilots, and we are happy that the National Green Hydrogen Mission has specifically kept provision for doing these type of pilots. And many companies have stepped up, including Tata Steel, JSW Energy, ArcelorMittal, and they have announced that they are investing in some green hydrogen related steel production, particularly with focus on European export market, where there is a demand for green steel. And that could be a good starting point. And as the prices for green hydrogen, it comes down with the reduction of both renewable energy prices as well as scaling up of electrolyzer manufacturing, I think India can become a global hub for green steel manufacturing as well. On the automotive side, as I mentioned, Tata Motors has been doing a lot of work on fuel cell buses for last few years, primarily working with Canadian or other technology companies. But we have also companies like KPIT and others in India who are working on now indigenous fuel cells for automotive applications. There are other companies, including NTPC, which is also bringing in focus on hydrogen blending into city gas distribution, as well as they are looking at it from the point of view of their renewable energy arm. And this is exciting that many of these large, both thermal as well as other petroleum or fertilizer industry companies are stepping up and looking after this as a green opportunity and sunrise sector and ready to invest into this area. We also have some of the international companies like Ohmium. They have set up their manufacturing plant in India, although it is meant mainly for export area. But right now there is a competition where who gets to $2 first, who gets to $1 first. So again, only time will tell how soon those timelines will be met. Some of these numbers and prices, price projections I have been monitoring since almost 2003, and we have missed some of these targets many times in past, even at government level, especially in US, the Bush government had a strong focus on hydrogen economy, and unfortunately almost $1 trillion were spent, but it did not lead to much outcome on that. But now I feel that especially with what has happened with the renewable prices going down and becoming the cheapest energy source, plus with the variability of renewables, you needing to find out additional consumption areas for absorbing renewable energy. I think green hydrogen makes perfect sense. The only one aspect I would like to mention is that many times people assume that green hydrogen or the electrolyzers are competing with batteries. And I think that is a complete misnomer or misunderstanding, because electrolyzer is right now the costliest investment in terms of making the green hydrogen. So you are not going to invest into electrolyzers and then operate them at 20 or 30% capacity factor and keep them idle by just using it when solar or wind energy is available in excess and not use it other time. And that's where I think we feel that wind, solar, storage, hybrid projects will be the key to success of green hydrogen strategy. And that's where I think we will find out a lot of exciting opportunities where green hydrogen is going to create additional demand, which will make the government's target of 500 gigawatt renewables a reality. Because without the kind of additional load and additional energy, green energy consumption in the industrial or fertilizer sector, it seems very hard to imagine what India will do with 500 gigawatt of renewables. So we think that actually renewables, energy storage, and hydrogen go all in together, and together they present a faster pathway for India to move towards a cleaner environment. Now, in this area, as IESA, we are spending a lot of effort on skill development and education. We have an initiative, IESA Academy, where we partner with many organizations. And again, we would love to also get both TUV, NTU, as well as IIT Bombay more actively involved with these initiatives, where rather than doing these one-off presentations in a year, we can plan more structured approaches for collaborative. We are right now on verge of signing a MOU with IIT Madras Research Park for doing and throughout the year series of activities for bringing such synergies together. We also have many of the online courses available in the learning management system online. So if you go to indiaiesa.info, you will find a separate tab for IESA Academy, and many of the past training programs are available for free, or if you become a student member, you can get access to most of these training programs for free. We have also created a IESA Green Job portal because we see many times, especially students who are in their final year come to us and they say that, okay, we have been working on some research, but we are not sure where is the exact opportunity. And that's where, again, if you are students, if you are looking at getting involved in industry, please create your profiles for free under the jobs tab on IESA website, and we'll be happy to connect you with for internship opportunities as well as jobs with more than 150 member companies of IESA. We also would love to have IIT, NTU, and other universities who are involved with this today's webinar to get actively involved as research members of IESA. We already have many universities, including Carnegie Mellon University, Stanford University, Pune University, VZTI, and others who are part of IESA. So again, if you get involved, then you can get access to many of the activities what we are doing throughout the year. We are also focusing a lot on startups, and I hope that at least 20%, if not 50% of you will be looking into entrepreneurship opportunities, because this is the area where, again, there are a lot of focus and support from government and industry. And already in last 5 years, we have many great success stories which have come out of the IESA startup ecosystem, including likes of Aether, Ampere, Bounce, Sun Mobility, 10log9, and many others. So we do feel that this is the area where many next generation unicorns will be coming up from the clean energy sector and e-mobility sector. And as a IESA, and not just as a CS, but as an entire IESA community, there is a very strong focus, and many of the IESA member companies are very actively looking at investing in promising startups. So if you are working on such ideas, I would encourage you to get involved with IESA ecosystem sooner than later. For more information in this area, you can get access to many of the knowledge papers which are usually available for free on IESA website. There is a IESA podcast called Emerging Technology Radio, which is available on all the podcast stations. We also have a quarterly magazine, Emerging Technology News, which also has a real-time website, etn.news, and there is a dedicated section on hydrogen. So you can, again, if you're interested, you can subscribe to free newsletter and stay informed about developments around the globe happening in this area. And if you need more information in terms of commercial grade information for market assessment or technology assessment, there are other reports which can be purchased as required. Last thing I would like to request all of you to mark your calendar for 22nd September. For last 5 years, it has been celebrated as a World Energy Storage Day. And during COVID, almost 30 international organizations came together to create a global virtual conference, which is a 24-hour marathon event, non-stop event, which gets held on 22nd September, where we divide the world in 4 regions. Australia to China as a region 1, India to Russia as region 2, Europe, Middle East, Africa as region 3, and North and South America as region 4. And we do 4 main sessions covering stationary storage, e-mobility, green hydrogen, and manufacturing and innovation as 4 sessions. And there are also additional 10 plus workshops which are conducted with partners, including with focus on solar plus storage, women in energy, urban air mobility, manufacturing and supply chain, and many others. So this is a completely free event. So you can go to the website and register for free. And if there is some interesting speakers which you want to nominate, feel free to do that. We have a call for abstract also available right now. I hope to see many of you and your colleagues join us for World Energy Storage Day celebrations on 22nd September. This is something which was evolved taking inspiration from the Earth Day movement, which gets celebrated on 22nd April each year for last 50 plus years. So we are trying to build a similar community with focus on energy storage, green hydrogen, e-mobility around the world in this using World Energy Storage Day. So with that, I'd like to end my presentation, and if there are any questions, I'll be happy to answer. Thank you.
Yeah, okay. Thank you, sir, for giving us insights in the energy, hydrogen industry in India. So now, like, if the audience has any questions, you all can raise your hands and we'll unmute you and you all can go ahead and ask. There was one question in the chat as well earlier. So Parnesh is asking if Dr. Subodh, you could share the sources where we can learn about clean, eco-friendly energy conversion, if there are any standard sources.
Sure. So I'll be happy to share the slides that I showed, and at the bottom of the slides, the source of the other information is also available.
Okay. So does anyone from the audience have any questions? You all can raise your hands and we'll unmute you.
Can I go ahead?
Yeah, sure.
Thanks very much, Dr. Subodh and Rahul, for these presentations. I'm actually interested in the more generally speaking, are we at a point where the main hurdle is that there isn't enough investment into this, or is it a technology hurdle? Because my thinking is that if it's investment, then it's a matter of policy, but if it's a technology, then perhaps it takes longer. So I'm just wondering, generally, are we looking at this being possible just through more people talking about it so that policies change, or is it that there are really big issues that would make it impossible to deploy on a large scale? That's my first part. And then the second part is, do you envision hydrogen being used for aviation, or is it too far into the future? I think any of you can answer. Thanks very much.
Yes, so I can take a shot at the first one. So in terms of the investment specifically, I think that has been something where people have realized that in last 2 decades, what has happened with solar and with battery technologies, that is, there is a very good likelihood that it will get replicated in this area. The only question has been that about the scale up and how do you provide the volumes? Because what happens with many times, almost for every technology, if you go to any of the top management consulting companies, they will end up creating these type of cost reduction trajectories, assuming anywhere from 10% to 16 or 20% sort of a cost reduction because of doubling of the volume. And then when you are going from like a 100 kilowatt scale manufacturing to tens of gigawatt scale manufacturing, suddenly you can see like a multiple X cost reduction possible. The challenge what happens is how do you provide that scale for the intermediate period? Because when the price reaches $1 or $2, everyone realizes there is a huge market and people will be ready to do it. But the challenge becomes is where will be the market which can absorb the technologies at a higher thing. And the good part is right now with the option for blending and with the greater focus on the clean environment and the climate change targets, there are this existing market where people already have gray hydrogen being used. So it is not that there is a new application where someone has to figure out if hydrogen can work or not. If you just start blending with 5%, 10%, even 20% kind of thing, that itself creates a multiple million metric ton market. And that's why there is a huge investment which is being poured. And many of the petroleum companies and other investors from the fossil fuel industry who actually missed out some of the investments on the EV or other areas, they are now really stepping up, and to some extent maybe they are overcompensating, but I don't want to complain about that. But there is a great amount of investment which is right now flooding the green hydrogen ecosystem. At least that's my view. Professor Subodh can add his views on that.
No, more or less, I agree with that analysis. There is definitely room for scaling and basically cost reduction from that perspective. New technologies would also be something that we will continue to watch. And I think the promising technologies there would be the solid oxide electrolyzer cells that could also be used from a carbon capture perspective or utilization perspective as well. So it's a little bit of both. We need new catalysis, we need new technologies for the devices, and we definitely need disruptive ideas in terms of what else is possible in that entire space. To answer your second question.
So let me just maybe clarify a little bit.
Sure.
And I understand. I think for any technology, there is still room for new things. I mean, even the traditional ones that we've had for a long time. But I mean, are we at a point where if we use the same technologies we have, but we put more money into them, would we be able to, say, run an economy on just hydrogen? Or is it still at the stage where it will be hard to do? I think.
No. Certain aspects of the energy transition can definitely be accomplished by putting more investments in it. But from a longer term perspective, if you really look at the overall efficiency of hydrogen generation as well as the overall cost, we need new technologies. So in a way, it's a similar trajectory in terms of what we have seen with either batteries or with solar cells. The cost reduction in both solar as well as batteries was done with existing technologies more or less. But newer technologies such as tandem solar cells can be disruptive, or newer technologies like beyond lithium, with using sodium ions or other forms of solid state energy storage can be disruptive. I can use a similar parallel with hydrogen. I think with existing technologies, a lot can be accomplished, but breakthroughs are needed with new materials, new technologies as well. To very quickly answer your second question on aviation,
yes,
I think the near term substitute for petroleum would be biofuels. In the longer run, different forms of hydrogen, either for more electric aircrafts, is one feasibility. Definitely, people have also looked at compressed hydrogen or cryogenic hydrogen, which can run with both turbines as well as other forms for aviation as well. But in the near term, it is more likely to be a drop-in substitute biofuels.
Also, just to add on that, on the aviation side, I think similar to what you're seeing on the automotive side, where the smaller vehicles being moved towards more of a battery electric vehicles. I think same thing will happen. There is a lot of work happening with looking at short haul, something like 10-seater, 15-seater kind of a planes, which can actually connect 100 to 400 kilometer kind of a flight range. I think that can actually democratize the air transportation quite a lot. Also, I think the urban air mobility is the area which is very exciting with air taxi or those type of services. Those also can become actually reality within next 10 years, where maybe the battery technology itself will lead to that adoption. But then if you're looking at like a cross-Atlantic flights or those type of a long duration flight, then I think just with the weight of the batteries and other thing, it becomes very unviable. And that's where I think hydrogen can be a long-term solution. But in the meantime, as Dr. Subodh mentioned, I think biofuel is definitely a alternative for that as well.
Thank you very much.
Yeah, thank you, sir. There are quite a few questions in the chat as well. So, Nimish, would you like to unmute and ask your own question, or should I just go ahead from here? Okay, then I'll just ask the question. So, thank you for the presentation. Are there any emerging alternate technologies to electrolyzers for producing clean hydrogen?
So really the three leading technologies from electrolyzers is what I mentioned earlier. These are the alkaline electrolyzers, the PEM-based or the solid oxide electrolyzers. There will be different versions of it that will come forward, but I don't see a completely new method yet in terms of replacing the electrolyzer technology completely.
Okay, thank you. Hope that answers your question. The next question is from Parnesh. What are your views in alloy E-cell? Can it be a future replacement to toxic batteries? And if you could actually mention the research journals regarding this prospect.
Actually, I'm not sure what he is referring to in terms, he or she is referring to in terms of alloy E-cell. I don't know if Rahul wants to address that. I do not know what is being referred to.
Yeah, I'm also not sure about the particular company, but I guess maybe his question is more about, rather than electrochemical batteries, there is work happening on organic batteries and other new things which are more environment friendly, using more sustainable materials. So I'm assuming that's the question. If not, please correct me. But see, this is a part where I think there is a sometimes there is a lot of hype and lot of misinformation being used in this area. See, most of the battery manufacturing nowadays has a way where it can be very, very environmental friendly. In terms of, there are many battery manufacturing sites which are almost zero waste sites, where people are using one, green energy for the electricity which is being used for the battery production, and also in terms of most of the materials which are being used are very valuable materials, because for advanced batteries like lithium-ion batteries, just the material cost itself is almost 60% of the cost of the battery. So almost every effort is being put in for doing complete 100% recycling of any scrappage or waste which gets generated during the production. And then these batteries now have life of almost 10 years, 15 years, or possibly even 20 years, depending on the chemistry, where you will be using and multiple times the amount of energy as compared to the amount of energy which the battery holds on a one single day or one single charge, right? So if you think of it as a total life cycle cost analysis, I think electrochemical batteries are much better alternative to what we are doing right now in terms of the fossil fuel consumption, where every unit you get generate, you end up creating more environmental challenges, and there is no recycling with fossil fuels, right? So this is a part where I think solutions are available. Obviously, lead acid industry has showed us the way, where there is globally more than 98% recycling is achieved by the lead acid battery industry. Where some of the problems have been is that if the local environmental rules and enforcement is not done properly, then companies have tried to cut corners. And even in places like US, where Excite Technologies, which is not related to Excite Industries, which is an Indian company, but Excite Technologies almost went bankrupt because they were not doing the recycling of lead acid and managing the waste for it, and they have a huge lawsuits right now in California. So some of these are not technical challenges, but these are more of a commercial and short-sighted decisions taken by the company management. But as in fact, with most of the advanced battery technologies which are there, the chemistry itself may have some toxic elements, but most of the batteries are completely sealed. There is no leakage happening during the usage of it. So if you just ensure the proper recycling at end of it, and there is a significant 60% of the value of the material that can be completely recovered, almost 95% plus of the value can be recovered at end of the life. And considering the commodity price increases which is going right now, especially for any batteries which use anything like cobalt, nickel, no one wants to let them go into waste. So we think that even the existing batteries can be used in a very, very environment friendly way. But obviously there will be new techniques which are being evolved for organic batteries. But we'll see. I think typically the commercialization.
Thank you, sir. Sorry to interrupt, but there are quite a few questions from the audience, so maybe we can like catch this later on. So from Chandrik, to ask both speakers, would it be viable for the world, including Singapore, with deeper explanation, to utilize all types of hydrogen for eco-friendly and sustainability initiatives? If so, how far, including possible predictions? Probably Professor Subodh could go first since he's asking for Singapore in detail.
So I think definitely hydrogen is the future energy source. And I think that's the only way we can substantially reduce our emissions and also use the hydrogen for synthetic fuels to take CO2 out of the atmosphere. So investing in green hydrogen is truly the only solution in the long term in terms of sustainable growth.
Dr. Rahul, could you add please?
Yeah, so in the Indian context, as I mentioned, that with the green hydrogen policy which is coming up, I think the blending project should start in 2023 itself, and they will be scaled up. If the initial projects are successful, then by 2025 to 2027 timeline, the government is looking at maybe increasing the blending to almost around 10 to 25%, and then by looking at by 2030 going to 50% or higher. So I think there is definitely a lot of opportunities for using green hydrogen in India. Now the key part is like how far we can start achieving some of the cost reduction with the scale and volume which is available with these blending opportunities. That will be very, very critical. So next 2 or 3 years are going to be very crucial to determine, do we really start doing it within next 5 years, or it ends up becoming just at pilot stage, and then it could take like more than 10 years. But I'm very hopeful that we will start seeing volumes being generated from 25 onwards.
Okay, thank you, sir. So the next question, electrolyzers currently use many rare materials to make. So do you see that as one of the bottlenecks in scaling up?
Absolutely. So I think non-platinum group materials from a catalysis perspective is a big area of research, not just from an electrolyzer perspective, but from all form of chemical petroleum industries. That is one of the significant topics of research and breakthroughs which are needed.
Okay, thank you. And what are the most promising methods for hydrogen storage, as H2 has low weight and like leakage and pressure are issues? Do you think that material storage will surpass liquefaction or compressed gas?
So again, as I mentioned earlier, there are maybe 3 different categories, right? You can storage at gas, and clearly the question asked does highlight the issues with storage of gas. Options of cryogenic storage as well as storage in some form of liquid organic storage are viable. There are 2 separate issues. One is storage, and in a number of places transportation. So both storage would need different solutions, and transportation would have different considerations as well. So if the storage and utilization is in relatively close proximity, then piped hydrogen should not be an issue. But if you're transporting hydrogen over thousands of kilometers, then there are other considerations that are highlighted. And these considerations are not just the percentage in terms of the weight of the hydrogen, but also the number of tankers which are needed for the hydrogen transport. Not all ports are able to take tens of tankers per day and unload the cargo associated with it. So it's a complicated question, and the end use and the transportation will play a significant role in the decision making.
Thank you. Yeah, so like one of the last few questions before the break. Where do we stand in biohydrogen production from wastewater treatment facilities?
That's a very good question. I think hydrogen definitely is available from wastewater treatment facilities, and very often it is looked at more as a byproduct than a primary method of production. But maybe Rahul has more experience in this field, and maybe he wants to add something more to it.
So I think this is a very important area, but generally I think again I haven't yet seen something which is really at a commercial scale. In fact, one of our company founders, Steven Fernandes, he had invested in a company which was converting trapped grease into biofuels, and ultimately later on actually it ended up becoming like a additional technology for just like a water purification kind of thing, which was eliminating some of the problems for the existing water treatment technology. So it depends a lot on the policies. I think if there are right policy support available for valuing the this, then it can take off. But more than even wastewater treatment right now, I think there is a lot of work happening, especially in India, in terms of looking at biofuels or biomass generated hydrogen as well. That's another thing which I think government is looking at allowing as part of the green hydrogen. So although most of the industry focus and big announcements have come in terms of focusing on electrolyzers, but there are many companies who are specifically focusing on the biomass based production of hydrogen as well as an alternate pathway for green hydrogen.
Thank you, sir. So Professor Subodh, since you spoke about transportation, why pipeline infrastructure can't be used for transportation like gas and crude oil?
So it definitely can be used. There is a crossover in terms of cost. So if the pipelines are used for transporting hydrogen and the pipelines are less than a few hundred kilometers in length, then it is viable. As you cross maybe a couple of thousand kilometers, then the pipeline-based transport is no longer cost-effective, and alternatives need to be considered.
Okay,
This
thank you,
one more
sir.
point there is that, as I mentioned earlier, that one of the issues that you cannot just use existing gas pipelines for hydrogen transportation because the brittleness of the pipelines are the thing that ends up becoming issue. So you need to have special pipelines. That means you are laying out a completely new infrastructure and not just using existing infrastructure for that. That sometimes people miss out and they just assume that, oh, we have already the gas pipelines available. Why don't we start using it for hydrogen? Unfortunately, technically that is not viable.
Okay, thank you. So we'll be starting our next session at 3. So all of you who want to take a break can like leave and like grab some water or coffee and join us back at 3 p.m. There are a few remaining questions like how will gas distribution change in different countries in the future to ensure sustainability is achieved in those countries?
I'm not fully sure I understand the question. From a gas distribution perspective, I'm assuming the question is relating to hydrogen. And as mentioned by Rahul as well, hydrogen if you use the existing pipelines, you'll have hydrogen embrittlement. So you need new infrastructure. And as I also mentioned previously, there'll be a crossover from a cost perspective. So it depends on the countries we're referring to. Some countries would have local production. Other countries would be net importers of hydrogen. So the solutions are different for different countries.
Okay.
And the other aspect is, apart from the pipelines, again, you also need to start focusing on the end applications where that is used, right? So especially if you're doing blending with even natural gas and hydrogen, then you need to make sure you're looking at either the burner or anything where you are burning the natural gas. It also can accommodate the hydrogen thing. So you need to pay attention. Again, it's not rocket science. There are already many companies who are already working on their existing gas turbines for accommodating easily up to like 20-30% of hydrogen. There is a projections which I have seen by 2030, many of the large companies, including likes of Mitsubishi, GE, they are promising their turbines will be able to take 90% or higher hydrogen. But there will be some changes and modification required if you are looking at using hydrogen blending with natural gas for existing equipment.
Okay, yeah, thank you, Professor Subodh, and thank you, Dr. Rahul. It was really great interacting with you, and we learned a lot about hydrogen from you all. All those participants whose questions have not been answered, you can probably reach out to them via mail, or they'll be providing the slides, so they'll have their contact details in that, and you can reach out to them through that. And yeah, really looking forward to see you all at 3 p.m. for the session on green economy, 3 p.m. IST. That's in around 5 minutes. And yeah, thanks a lot. Sarvash, Parisa, do you all have anything to add?
I think thank you both the speakers. It was really nice to learn about hydrogen, and I think we'll be back in 5 minutes. Yeah.